Hashrocket Book Club for the day of today, January 25th, 2011. Hope you're doing well out there. We're going to talk about functions. So, functions. I hope everybody's read this chapter. It's really long. We're probably not going to make it through the whole thing today. And there's some weird stuff in it that Shane and I have found that might or might not cause some issues, but we'll see. So, the two main features of functions in JavaScript, we're picking up on page 57, that make them special is that they're first-class objects, and the second is that they provide scope. So functions are objects in JavaScript, just like everything. They can be created dynamically at runtime, during the execution of the program, so prior to the execution of other things, can be assigned to variables, can have their references copied to other variables, can be augmented, except for a few cases, can be deleted, can be passed as arguments to other functions, can be returned by other functions, and can have their own properties and methods. Functions are super flexible in JavaScript and can do all sorts of stuff. You can have a function that passes functions, returns functions, and then he makes a complicated example here where B can accept a function C as an argument and execute it, can return the function D. Don't worry about it. Functions are cool. Page 58.
And next page.
And next page. Oh, that's the gist of that page. There's an anti-pattern here with a function constructor. Don't use the function constructor because it evals a string of code. But he's just explaining how a function handles information. So blocks don't create scope in JavaScript. If you're familiar with JavaScript, you should know this. It's something that's defined within an if statement. Can be accessed outside of the if statement. Only functions create scope in JavaScript. Saying that curly braces don't provide local scope means that if you define a variable with var inside of an if condition or inside of for or a while or anything else,
or with,
that doesn't mean the variable is local to that, like I just said, except then I just read it from the book instead. So here's some weird disambiguation of terminology that actually might cause more problems than it solves. He talks about a named function expression, which he's calling a situation where you have a var of add, and then you equal it to a function that's also called add. So you've got a named function that's also being used in a variable expression. This isn't super common. You're not going to do this a lot. The reason that you would want to do this, and he explains it in a minute, is in case you want to access the function from within itself. That's why you're making a name of add on there. So you can call it within itself. An unnamed function expression is a lot more common because we're usually not going to write recursive functions. So that's the var add equals function A and B. So it's an anonymous function because technically the function doesn't have a name, but you are also getting a reference straight to the function. So that's a function expression. The weird thing is that's also could be called a variable declaration. You're just declaring a variable with the value of that function. So his use of the word expression here is a little bit off-putting because then he talks about function declarations on the next page, which is just a traditional like function foo. But like I said, the other could be called a variable declaration where you're declaring the variable to be a function. So it's just not great terminology. I understand you had to do something here, but we're gonna do our best to work that out because he starts using all those terms pretty often.
Yeah, the term that most people use anymore for what he calls a function. What do you call it?
Function expression?
No, declaration.
Function declaration.
You'd normally call that a function statement instead. I mean, I understand using function expression. That's fine, but yeah, function declaration's kind of weird.
So he has a weird paragraph here. We're looking into this today at the top of that page 59. When you omit the second add in the function that's var add equals function add, you end up with an unnamed function expression. This won't affect the definition and the consecutive invocations of the function. The only difference is that the name property of the function object will be a blank string. But the name property is not ECMA standard and not available in many environments anyway. So you're always going to want to use a named function. You can't just get to the, if you have to get into that function, you can't just count on accessing this name property. He says it's useful in using debuggers. He says it's useful in using debuggers, which is fine. You can use it for debuggers, but he says, or when calling the same function recursively from itself, which, you know, kind of sounds important to your JavaScript running properly. So you can't, even if you can't count on that being available in the environment that your client or user might be running the JavaScript, then it's a useless thing.
Yeah,
we don't like doing with that.
Yeah.
So, the only other part of this section that's worth mentioning is that the trailing semicolon in a function declaration or statement, no trailing semicolon, and in a function, what he calls a function expression, which is a variable declaration, so there should be a semicolon, even though they're both closing a function scope. One of them is a statement, and one of them is a variable declaration.
And that practice is based on the assumption that you're using JSLint too.
Mm-hmm. JSLint will catch that stuff. Mm-hmm. So, yep. And if you were here for previous weeks, you will recognize this section on hoisting because it's essentially the same thing as when he talked about variable hoisting. Functions behave by the same rules where, excuse me, if you are calling something var later, it gets defined up here. Like I said, he doesn't spend much time on it. He doesn't explain it as well as he does in the other section. So if this section doesn't make sense to you, go back to the variable hoisting section and check that out. And then he's got a very strange and extremely ambiguous and possibly incredibly wrong paragraph right here on page 60. Excuse me. So let's read it together, shall we? Function declarations can only appear in program code, meaning inside of the bodies of other functions or in the global space. We've had a discussion. We don't know what that means at all.
Yeah.
I don't know where the third context is.
Right. What is outside those two?
Function declarations can't appear on your notebook if you in your hand. I think that's what I don't know. It's some other dimension.
If they're in your head, that doesn't mean they are instantiated.
Yes. So everything in JavaScript is in either the body of a function or a global space. That's a totally confusing line.
Yeah, it's either global or scoped.
Yeah. And so then the definitions cannot be assigned to variables or properties or appear in function invocations as parameters. This isn't true at all.
And
you
what
can
he
do all of
covers
those
after
things.
that.
Yeah.
Even a named one?
Yes. You can name a function.
I've never tried that before, but
Yes.
that's the way I take it.
We ran it this morning. We ran a bunch of different. We ran a named function and we named it within a parameter.
Can't be relied on in all browsers.
That I don't know. We were using the WebKit. I was using the Chrome
V8.
console. So I haven't checked it on lint or anything. I haven't checked it in JSLint. But even if that is true, that my argument for this section being ambiguous still stands because he doesn't explain why or anything. And I mean, WebKit's pretty standard and it works fine. Now I haven't tried it in IE and I haven't checked to see if JSLint freaks out. But he just, I mean, that's a pretty important thing if you can't assign function definitions to variables, properties, or in function invocations as parameters, and he doesn't go into any explanation there as to when that may or may not be true. So big grain of salt on that one. Although you really shouldn't be putting named function declarations as a parameter anyway. It's worth some research to find out whether if this paragraph is at all true, and if so, in what contexts. So there you go. Functions. So he talks a little bit about the name property here, and again, the name property is not implemented the same everywhere. But so the rule of thumb here, all the way down to the end of this section, is don't, like if you're recursively accessing something in a function, just name the function and access it that way. Shane was also looking at arguments.callee, which is a attribute of the arguments variable that's accessible within a block. So you'd be able to, like, arguments bracket 0 is going to be the first argument that's passed through to that function. Arguments.callee is supposed to be a reference to the calling function, but that is deprecated, I believe.
Yeah.
Yes.
It was deprecated in ECMA script version 4, and that carries over into version 5, which at least as of today is actually going to be implemented.
Not allowed in strict mode.
Yeah, in the wonderful strict mode.
Right.
Also, so yeah, and then he talks about it here, and just like you said before, name is fine if you want to debug something, but you shouldn't be putting it in your code and relying on it.
Well, and I love how later on he's like, right here, he says, oh, well, it's problematic if you set a function expression to have a name that's different than the variable name, because I is going to throw up, basically. So if your variable.name property is going to be the same as the name of the variable you're setting it to, why would you even need the name property to access it? So if you set foo to a function, you can leave it unnamed and still access it with foo within any other blocks that occur inside of the block that this is currently in, instead of having to do foo.name, which is going to return foo anyways, you know?
Yeah.
Foo.name would return bar there. I don't know if you.
It would,
in some
right?
browsers.
But he's saying not to do that. He's saying not to name your function expression a name that's different than the variable name, because Internet Explorer may have issues.
So yeah.
Yeah.
Here's that function hoisting business expanded upon. Like I said, works the same as variable hoisting. Generally speaking, if you put your variable declarations at the top of sections, then you won't have any of these issues. So here's his section on callbacks, which is interesting. There's a lot of good stuff in here, but a lot of his examples are a little bit tough to get through. So, uh-oh, broadcast go off?
Yeah, I'm not sure what it is.
Oh no.
Let me press
You've just
pause
been
and
wasting
read
time. We are back
yeah.
live again.
Alright, and we're back. Oh, wow.
And what did you
I
do?
went to refresh my browser and rotated the page of the book. Computers. Alright. So we have 3 viewers now.
Shay is hiding himself.
I think it's probably just 3 people in this room. That's alright.
Shay is watching himself on.
Turn the sound off, the delay. This is awful.
Alright. So, callbacks.
Callbacks. Callbacks are useful if you want to define a functionality that gets executed within a function, but it allows you to keep the function generic. So you have a function, and this is a bad example, and we'll have much better examples later. So the one section here in the top of page 63 is a nice little tidbit, which is parentheses execute a function, whereas in this case you only want to pass a reference to it and let the parent function execute it. In other words, call it back. So write code parentheses introduce bugs. And I just like that because it's nice to know the parentheses execute functions. That should have been put earlier in the book for people who are curious about such things and don't know it. So here's his callback example, which is, like I said, some of it is good, some of it's really weird. So if you have this find nodes function, it just walks through and does a bunch of stuff to find nodes in some giant amount of nodes. So you don't want to run this function multiple times, if at all possible. So one way that you could do it is what he has here with this variable hide, which is a function that goes through the nodes and then sets them to display none. So, but what happens here is that find nodes is going to run. It's going to give you an array of 4,000 elements, and then hide is going to run over that array of 4,000 elements and hide all of them. So you're running through all this stuff twice. So that's inefficient. A much better way to do it is with a callback, so that as findNodes is walking through the array, when it finds stuff, it does something with it right then. So he refactors findNodes to accept a callback. So you have a callback argument passed in here. And then the way that he does this is totally silly. So yes, that's a good example of when to use a callback function. But this is a horrible example of how to run the callback function. So what he's doing here is he's checking up here to see if the callback is a function. And if it isn't, he's just setting it to false. And then down here, he's just saying if callback, and then run the callback if it isn't false. That's one extra, like you don't have to do that. Just say, if down here you take this line, if a type of callback triple equals function, then run the callback. That's it. It's one if statement. You don't need to like reset callback to false.
For that matter, why not just say if callback? Because I mean,
That
are we really
work.
worried about someone? What?
That does work. Yeah. You
Well,
can
Are we
just say
really
if
worried about
callback.
someone? Oh shit, they passed in a string.
That-
Well,
that's
let's just
really-
silently ignore it then.
Yeah.
No, it needs to fucking blow up.
Well, there you go. Like.
Damn it.
But and what I think what he was trying to do is set it up so that, oh well, you know, you're only running this condition once, but you're not. You're running it
Well,
I
in-
times
In
plus
theory,
one.
type of could be more expensive than just a Boolean query, but I don't know. I still think it's redundant.
Yeah.
Yeah. Well, what he has here is triple redundant, and what I was suggesting is double redundant. But yes, you could always also just say if callback, and
Yes.
it would explode on you if callback wasn't a function. But anyway, other than that weird thing, it's a decent example of how to run a callback function, because now you can, you could have a findNodes, you can run findNodes and hide stuff. You can run findNodes and show stuff. You can run findNodes and then just pass in whatever you want the callback function to do. So
Surround
it keeps
them in a blink tag.
surround them in a blink tag. So that allows findNodes to be modular, and I mean that's a good technique to know whenever you're doing DOM implementation or DOM DOM manipulation and traversal and such. And I mean you will often see callbacks in tons of jQuery code and plugins and stuff like that. So let's see, and you can also just pass an anonymous callback, so you can just say findNodes and then throw in the function declaration right then and not even name it, which you will also see a lot of that in jQuery and in jQuery examples. A lot of the time, the last argument in a series of arguments in a jQuery method is the callback function, and you can either define your function somewhere else or just write it right there. So this is a much weirder and less effective example, and I think is what he's trying to get here is possibly good, but it's a case of his example code creating a non-problem. So I'm talking about the bottom of page 64, top of page 65, callbacks in scope. So what he's trying to illustrate here is that you can't count on this in this situation to refer back to my app. So you have this var of my app, myapp.color, myapp.paint equals function, and so then inside of this function, node.style.color is this .color. The problem is if you're running this within another scope, this .color is not going to get to my app. It's going to get to something else, whatever scope it happens to be in. So
If it's not otherwise bound, it's going to be the global object again.
Mm-hmm. Or it's going to be like, it's going to go to findNodes. It's going to go to whatever findNodes is living in. So here's the problem: is like he's trying to illustrate this point, but the solution to this problem is just for the myapp.paint function to be node.style.color equals myapp.color. The end. You already know that my app is right there because you've just defined the function within the context of my app. You don't have to use this at all. This is a non-issue. That's how you would fix this problem. Unfortunately, I guess he wasn't able to come up with an example that would actually require a more complicated solution, because then he builds this really complicated solution involving the call method and all sorts of stuff in order to provide myapp.paint the proper context to use this. So what you have here is this callback, and then you also have to pass in a callback object to find nodes, which is then going to provide a context for callback to operate on. So
Hey, look, it's only doubly redundant.
yeah, it's a little bit crazy because, and he hasn't talked about the call method yet. So if you're not familiar with the call method, this is an even worse example. If you go down here and you've got verify nodes equals function, callback, and a callback object, and then he's got his conditional, which by the way is the one we were talking about earlier, where he just says triple equals function, and he doesn't deal with that other setting it to false business like we just suggested doing. So that was weird. And then callback.call, and then he passes in callback object and then found. So what call actually does here is that allows callback object to be this. So within
Yeah, it changes the scope.
it changes the scope to this. That's what call does. So that's his super roundabout solution instead of just getting rid of this and just saying myapp.color up here at the top. So yeah, that's what he's created a non problem and then shown a crazy solution to it. But the important thing to understand here is that scope still applies with callbacks, and the scope is going to be whatever function the callback happens to be taking place in, and it's not going to be whatever variable the original function is assigned to, if that makes any sense at all. I really, really hope it does. Yeah. This all goes back to just understanding what this is and where this is being used. So, let's move on. I hope that was that. Does that make sense to you guys?
Question in the chat room about this stuff.
Oh, really? Awesome. Should you avoid this when using callbacks? Should you avoid this when using callbacks? I would say that probably, unless you know that the context of your call, you know what this is going to be. Because in this particular example, it's just a bad function because this, in this situation, is going to be myapp only if it's not being used as a callback.
Well, I guess the bottom line, there are techniques that whoever is invoking the callback can use to set this to what you want. Like in Jquery, all those functions,
Yeah.
they're all callbacks, so that this is always bound to the current element, and that's fine because,
Yeah, it's all down
You
to
know.
the ocean. Yeah.
So in jQuery you can count on this being the current object.
yes. But if they have not taken care to do that, it's just going to be the global object.
Yeah, if this were rewritten, this example from var myapp on, if that were rewritten in a way that myapp was a prototype, then using this .color makes sense in that method on that object. Because you're going to create multiple instances of this. You can't refer back to myapp because you may have a variable A, a variable B, and a variable C, all three be an instance of myapp.
Mm-hmm.
So if you refer to myapp.color, you're referring to the prototype property of color rather than the individual object property
Right.
of color.
But in his example, myapp is
Right.
just some variable somewhere, and you're going to have one instance of it because it's myapp and there it is. So yeah, so this in that particular case is unnecessary. So I mean, this, I don't know, your answer is, as long as you know what this is, then you can use it. You just need to understand when it is and is not the thing that you think it's going to be. That was a circular answer. That was kind of a non-answer. I apologize. Cool, thanks. You're welcome. Let's move on to asynchronous event listeners, which isn't really, I mean, it's just a practical application of a callback pattern. So there are, let's see, a simple example of how console log is passed as a callback when listening to a click event. So you can just add console.log on the event listener for click. I mean, if you use jQuery at all, you've added some events to things. All of those are callback functions. You're taking a generic function such as key press or mouse over, and you're defining a function that's going to be fired when key press happens.
Yeah, it's not identical to what jQuery is doing though, because if you use the addEventListener method, you're attaching one function to the click event. You can't attach multiple functions to occur in series. So once you create a new addEventListener on that particular
It
element,
overrides the old one. Yeah.
right?
Yeah, so strict JavaScript is there's one event listener and you've just overwritten it if you already have one. jQuery conveniently adds them to an event queue, basically. So timeouts is also our callback pattern situation. It's pretty simple. Passing a string instead of a function pointer is a common anti-pattern similar to eval in the last line of that section.
Yeah, if you, not that you should, but if you ever went to W3 schools and looked at their documentation for set timeout, it suggests that you pass the call to that function in a string. So set timeout would effectively evaluate the string as JavaScript and call the function.
So don't do that. Pass a variable to set timeout.
Yeah.
Callbacks in libraries. This happens all the time. Most jQuery libraries are going to have a callback in it. If you really want to, if you really want to dive into it, there's one example of a couple of callbacks is, and probably my most respectable bit of published JavaScript is the table sorter on my GitHub. So if you go to github.com/CameronD, the top item on there, the only one that's really up to date and solid is a jQuery table sorter with it's got a test suite and stuff. And there are a couple of either one or two callback functions in there, and you can see how you can hook in, and basically when the event of clicking on a table header to sort the table fires, it checks and runs against a callback function right before it does anything and right after. So in a situation, one of the ways that I use that is there's a table that I had to sort where the first row of the table was actually it was a list of cities, and then the first row was actually the full state statistics in this table. And so when you sorted, you didn't want to sort the state in with all the cities. You wanted to keep the state on the top. So what the two callback functions I used for, the first one pulls off the first table row, which is the state, then lets the plugin sort all the cities, and then the callback function, once it's done, I then appended the state back into the top of the table. Prepended. Yeah, prepended it to the top of the table. So that's just a simple example, and what was nice is any good jQuery plugin is going to be able to handle that kind of stuff, where you can screw with what's going on inside of this plugin without having to customize the plugin to handle it. So there you go. And don't look at any of the other stuff on my GitHub, because none of it's as good as that. Thanks. So there you go. Returning functions. So you can return a function. This is nuts, and there is a arguable reason to do this if you are trying to make sure that certain values are private. But it's more of I think this is more of a academic exercise. Mm-hmm. So if you look at bottom of page 67, you have this var of setup, which is a function that then sets a variable of count to 0 and then returns a function that returns, count plus 1. So you run this var next, which is setup, so you're running setup. What you're returning then is not this count of 0 line, you're returning the function. So then every time you run next, it actually adds 1 to the count. Because it's not resetting it to 0. The variable count 0 line only happens the first time when you run setup. So it's essentially more or less a private variable.
Yeah, and if you take this and repurpose it, just know that if you set more than one variable to the return of setup, each of those variables is going to have an instance of count rather than them sharing the same count instance. Mm-hmm. So calling one and then the other is not going to increment the same variable.
Right, so if you had a var next of setup and a var foo of setup, you run next, it's going to be 1. You run foo, it's going to be 1. You run next, it's going to be 2. Foo's still 1, because they're separate. even though they're both called off of setup. So self-defining oh, by the way, and he uses this to be totally ridiculous in a little while, so just a teaser. Because here, is this it? Yeah, I think
Yes.
this is it. This is bad. I'm going to go ahead and say, for a book called JavaScript Patterns, I don't think he does enough work making it clear that this is essentially an anti-pattern. This is what's called a lazy function definition. And the idea is that the function, so the scare me function, does stuff, but then redefines itself as a totally different function.
And this it could be very problematic depending on how you're using scare.
Right. And the purpose of this is supposed to be in case you're wanting to run some initialization code the first time a function is run and then run different code the next time. But there are much clearer ways to do that. For example, having an initialization method called init or initialization or something.
Which he uses later on.
Which he does use later on. This is a great way to have your coworkers hate you because it's weird and probably not very intuitive if you don't know what's going on.
Yeah, if you want to play around with this and see why this is a terrible idea, set this code up somewhere in some sort of environment, and then set an object property, so like obj.scareMe, set that equal to scareMe, and then call the scareMe function, and then call the property scareMe.
Yeah, he talks about that in a little while.
Okay.
Yeah.
Yeah, it's not what you think it's going to do.
So a drawback of this, and then he does spend a paragraph talking about the drawbacks, but he still doesn't call it an anti-pattern, which is really annoying. A drawback of the pattern is that any properties you previously added to the original function will be lost when it redefines itself. All the code will be lost when it redefines itself because it's redefining itself. Also, if the function is used with a different name, for example, assigned to a different variable or used as a method of an object, then the redefinition part will never happen and the original function body will be executed.
Well, it's not necessarily that it'll never happen. It'll never happen for all pointers to that function.
Right, and he explains that, we're not going to delve into this. This is an example of why, basically the next page is just an example of why you shouldn't do this, because it's going to do different things based on whether it's a property or assigned to a variable. It's an anti-pattern. Don't redefine your function within your function.
Yeah, nobody is going to expect that calling a function or a method is going to redefine the method.
Right. Yeah, it should be pretty basic that if you call a function and then you call it again and it does something totally different, that's probably something you should avoid. So, and again, the idea is that it's initializing in some way, but there are ways to initialize that are a lot less obtuse. Excuse me. This next section, immediate functions, it allows you to execute a function as soon as it's defined. You'll see this a lot in web code, just because it allows you to build a scope and then execute the code within that scope and keep your code safe from other code. And keep everything out of the global scope. You should pretty much always keep everything out of the global scope. So this little wrapper, the cute little wrapper at the bottom of page 69, is what you should pretty much always wrap your code in. There's an alternative in 70, but JSLint prefers the first one, which is a weird way of saying that JSLint's going to tell you have an error if you use the second one, so don't use the second one. So that's that section. He spends a lot of time talking about that. But essentially, like we talked about earlier, open close parentheses calls the function. So all you're doing here is calling an anonymous function and then immediately calling it thereafter with the open close parentheses. Parameters of an immediate function. This is an interesting technique. It's actually can be really useful, especially in DOM manipulation situations. So at the bottom of page 70, this function has two parameters of who and when, and then down here, when you, in the open and close parentheses, you're passing in who and when. Well, this is really useful. Say that you have some JavaScript code on a site that you have a bunch of unrelated things being processed on the same table, and so you don't want to run every time you want to get to the table. You don't want to walk down the DOM, and maybe you don't like want to have you want to enclose all this stuff in a way that doesn't just have table variable floating out with other code. So what you do is you have this open parentheses function, and then in the parentheses you have your variable name for the table, like customer table or something. You do all your code within the brackets, and then in the open close parentheses at the end, that's where you put your jQuery to walk through the DOM to get to that table.
Mm-hmm.
And that can be really clean and nice looking because you've saved yourself a variable declaration and created a nice little package for whatever you're doing, for whatever like unrelated to things you're doing to that table.
Yeah, then if the selector changes in some way, you change it once instead
Yeah.
of every single time.
And it helps you organize your code because it allows you to say, here's all the code related to doing anything with this one table, and you've taken care of it. So big fans here of that pattern, and hopefully that is a more useful example than the one that he gives for you being able to access the global object in a scope, which I don't know, that's a lot less practical. That I'm talking about the one on the page of or in the top of page 71.
Mm-hmm.
So, returned values from immediate functions. You can get values out of immediate functions. The usefulness of this is described on page 72 with this var o equals message and then get message and all of this stuff. Because JavaScript will evaluate functions before it evaluates anything else. So there might be a situation where in order to have an object, to have your JavaScript execute properly, you need to make sure that certain stuff is evaluated before other stuff. And that's, his example here isn't really a case of that, it's just a demonstration of how to do it. But it would have been nice for him to have an example of it, but it's a little difficult to provide an example of it, I guess. But there could be a situation where you want to make sure that one of your attributes is has been evaluated totally. So you wrap it in a function and then call that function. And so o.message is going to be evaluated first in this situation. So yeah, that's yeah. Can you think of a specific example where you need to do that?
Not an example, but what you would normally see written out in JavaScript code when someone creates an object like this and they need to do some processing in order to get the value that they want in the property. After this object is created, so like under this usage comment, you would see something like o.message equals what plus blank space plus who, and instead of keeping that outside of the object instantiation, you can put that inside the object instantiation by throwing it in an anonymous function. So it's an easier way of keeping the object initialization within the object literal. That makes more sense.
So, and yes, he does talk about here benefits and usage of self-executing functions is keep the global namespace clean. Like I said, you shouldn't have anything floating around in the global namespace. You should always be wrapping your stuff in something like that. So here's a better pattern on page 73, immediate object initialization. It's not the greatest pattern, but it is clearer than the self-redefining function nonsense. At least here he's using a function or a method called init that is a function that does some stuff, and then it immediately initializes. This isn't, I mean, a super common pattern that you're going to see, but hopefully if you've been following how these blocks work and how these immediate initializations work, what he's doing here is what makes sense for you. So there might be a situation where you want to make sure that an object has been initialized with a bunch of stuff as soon as it's created, and that's what's happening here. Any other comments on this?
No.
So the one note that he has, this pattern is mainly suitable for one-off tasks and there's no access to the object after the init has completed. So again, one-off tasks, not, super common in general. So I mean, and I guess it would be more common if maybe you're writing a game or something that has a bunch of prep to do before it can just be executed. In terms of websites and behavior and interaction and stuff, one-off tasks are a whole lot less common. So this, we are boycotting the init time branching section. His example is something that you shouldn't be doing at all, and he appears to think that it's an okay thing to do, which is browser sniffing. Browser sniffing is frowned upon almost entirely, even in terms of looking for functions, which is what he's doing. It's just a bad technique. Any library that you're using for browser-specific stuff, like Jquery, is going to be much more up-to-date with all of that stuff and is going to handle it better than you probably could handle it yourself. I mean, Jquery isn't the only one. All of your main JavaScript libraries are going to handle browser sniffing. And they do it in more complex ways than just looking for this one function. So I don't think this is a smart way to go about this. But the example that he's trying to show is that instead of every time you run utils add listener, it runs this triple if statement. You can go ahead and run it once and assign it to utils add listener in some sort of initialization, and then it's a value on add listener instead of a function on add listener. So whenever you access it, you're just getting the value off of there instead of it rerunning the function and figuring out what the value is every time. So that's a useful thing to know, but the pattern that he presents here and the problem he presents is, well, the problem's a non-problem and the pattern is not great. It almost makes it look bad because his after is 3 times longer than his before example. And really, the point here is just, if you're going to be accessing a property a lot, abstract out the function and then initialize that function into the property. So if you have, foo.color, make sure that foo.color isn't a function that's parsing out a RGB value from something. If that's always going to remain the same, initialize that somewhere else. 4 minutes, all right. Initialize that somewhere else. Run a function that's just like init that assigns foo.addColor as to be a string, and then you're done. Make sure you don't run it every time. That's all that he's trying to say there, and he says it in a crazy way. Let's see, how much more do we have here?
We were going to stop on the next.
Configuration, okay. Well, we have 3 minutes, so we'll do this real quick. I was going to spend more time ranting about this memoization pattern stuff. This is a bizarre page and a half. This idea of stringifying arguments in order to create a unique cache key in an array of a cache function is bonkers. Like, you could do that, but that is in no way a pattern for anything, and it's more of like, hey, check out this cute thing I did one time. So we're going to skip that in the interest of time, but if that confuses you or makes you upset inside, don't do it. It's a cute thing that you might see in someone's code, and it would help to understand how he's doing it, but it is in no way a pattern that it should be common. And the last thing we'll look at today is configuration objects, because it's nice and refreshing, and you should always use these pretty much. If you have more than 1 or 2 parameters for a function, throw them into configuration object. Any good jQuery plugin is going to have a configuration object instead of like a jillion parameters. Even in the dark, scary world of PHP, even WordPress finally has configuration object instead of like a million parameters all around.
This?
Huh?
Why do you know this?
Because I used to use WordPress, and WordPress used to be like, get comments would be a function, and then you would pass it 12 things, and it would just be like blank string, no, yes, no, yes.
Because you need to send.
You need to get to the,
argument number 10 or something.
Say you want to get to argument number 10, you have to write in 1 through 9 in some way in order to get to 10. It's bad. The middle of
it is referred to as, what is it, Jim Ryrick calls it connaissance of position. Yeah. Where I mean, there's the only thing significant about that parameter is you got to know the order rather than some associative name.
Mm-hmm. And associative
The
names
third
are
argument
always
happens
better
to be the ID.
because they're names. Yeah. So middle of page 78, super important. You should always do this. The cons are not even cons. The cons are you need to remember the names, which is a lot easier
can
than
look it
remembering
up.
an integer position. And property names can't be minified, but you're fine. Don't worry about that.
Well, they.
And that depends on the software using to minify it too, I
Yeah.
believe. So.
Google Closure will minify it if you tell it to specifically, but there's occasional problems with that.
Cool. And that's where we're going to leave off this week. Next week we'll start in on currying, and that'll be awesome. And I'm anxious to see if his currying examples are any more or less practical than
Yeah.
some of these examples.
There's actually, if people want to read up on that beforehand, there's also a good blog post on, it's unfortunate, but it's Microsoft's developer blog that Ben Allman did recently that I think goes into better explanation of this pattern than the book does. So.
You got a link, Andy?
Yeah, you want to tweet that?
Yeah, I'll find the link later and tweet it on the Hashrocket Twitter account for anyone that wants to check it out.
Cool. All right. I think that's it. Thanks for watching, everybody. We'll see you next week. Same time.